Hi there, I'm Matthew, and today I'm going to walk you through how you can scale training from zero to hero from your laptop all the way to the cloud using Oumi. Specifically, how you can scale these jobs up to running on many GPUs on cloud providers. So let's get started. So what I'm going to do first is I'm actually going to spin up the command and a cluster for running these jobs on the cloud. I'm going to do this first because it's going to take some time, so we can start it, it'll run in the background, and then I can walk you through the actual configuration that we're going to use to spin up this cluster and run this job. So to get us started, what I've done is I've actually cloned the Oumi GitHub repository. This is all public info everyone has access to. Inside of our configs folder, we have our recipes, and these recipes are the springboards that are, they act as springboards for you to jump off and get started and reproduce results that we already have available in Oumi. So today we're going to do a repro of Deepseek R1. Specifically, we're going to do some supervised fine tuning on the Llama 70B distill of Deepseek. So you can see here, we have Deepseek SFT and our Llama 70B distill. So we're going to take this GCP job or Google Cloud Platform job and take a quick look at it. When you open up this configuration, which I'll go over here in a minute, just know that at the very top, there's a usage section, and this will tell you exactly how you can run the command to actually use this configuration file. So I'm going to copy this command and we're going to kick off the job and then we'll talk our way through it. Let me actually get over off screen so I can copy everything we need. Great, and we have the command here. So now I have my terminal set up, and let's go ahead and kick things off. So I'm going to copy and paste that job that we just specified that says we're going to run Oumi Launch up, specify a configuration file and a cluster, and we'll run things. So let's get it started. Okay, great. So what's going to happen is I'm going to put this off to the side now, but this will be taking a look. We're using SkyPilot here to find resources on Google Cloud Platform. It's going to look for a region that has the needed resources, which we'll talk through in a minute, and we'll actually spin up a cluster there, then copy my local bits over the machine and run our actual job. So while this is getting started here in the background, let's go ahead and take a look at the configuration file. So first off, I do want to mention on oumi.ai/docs, our documentation page, you can get a full overview of what this configuration looks like. I've written a great tutorial that you can use there that goes in more depth than I'll go through here about what each of these fields does. But for today, I'll give you a quick overview of what this actual config is doing, and we'll walk through it together. So let me zoom in just so we can see a little bit better what's here, and we'll walk through each of these fields. Let me also, there we go, zoom to the left. Okay, so at a high level, the fields you need to worry about here is the name of the job. This is, again, a job config, so the actual class you'd want to look for, we have listed here, is our Oumi job config. This is the name of the job that's going to be run. Pretty simple. But then below it is actually a very important piece. It's going to be the resources needed to run this job. You need to specify the cloud provider you want to run on. I'm going to run on GCP because I have some credits on GCP right now that we can use. And then you need to specify, besides the cloud that you want to run on, the actual topology of accelerators you want to run on. So in this case, I've specified I want A100 80 gigabyte GPUs, and I want 8 of them. So that's going to be the resources for one node. And I have the option later to choose the number of nodes, but know that this is the topology for one node in your cluster. I've also specified whether or not I want to use spot jobs. That's like whether your job can be preempted or not. I don't want my job to be preempted in this case, so you have to pay just a little more for these cloud providers to do that. And then the disk size here, I chose 2,000 gigabytes or 2 terabytes approximately to make sure I have enough space to download all the models. Now for multi-node, as I mentioned, you can actually specify the number of nodes. If you leave this as 1, we'll just do a single node with this topology, but I could also spin up 2 nodes or 3 nodes and actually have training run distributed across those nodes. We'll just do 1 node for sake of simplicity for this tutorial, and then we specify our working directory. Working directory is the bits that you're going to copy from your local machine to the remote machine to actually be used or available when you run your job. In this case, I'm going to copy my working directory, which is just our GitHub repository, and we should be good to go. This is mostly just so I'll have access to all the configurations that I mentioned on the left-hand side here, like our actual train configuration and things like that. You can also mount local files, so you can have a one-way mount. This mounts from your local machine to the remote, but it's not synced backwards. This is if you want to actually mount like maybe credentials you have on your local machine to your remote machine. Here's an example using WAND-B credentials or weights and biases. You can also do storage mounts though, and this we will do. A storage mount here is particularly useful if you want to actually mount a storage bucket. In this case, I'm going to use a GCP bucket that I own and have the output of a local directory on the remote map to this storage bucket. So in this case, the remote machines / output directory is going to map to this Google Cloud Storage bucket. Okay, and there's only a few fields left that I'm going to talk about here. One is environments variables. These are the environment variables that will be available during the setup command and the run command. And the next two pieces are setup and run. And now it's fairly simple what they actually do, but you do need to note how they interact with jobs. The setup command for most cloud-based providers is only run when a cluster is set up. This means it's run once on cluster instantiation and not again until a new cluster is turned up. Whereas the run command is to run once for every job. So typically you'll set up a cluster, you might run 1, 2, or 3 jobs. That means for that cluster, your setup command is only going to be run once, but your run command for each job will be run whenever those jobs are actually run. So do bear that in mind when you define what happens in each. So to that end, our setup command is just doing an installation. We're going to install UV so we can actually pip install a little bit faster. We'll install the GPU package for Oumi, and we'll install Hugging Face Transfer and use that to download the weights for our model a little bit faster than it would be just downloading them otherwise. Our run command actually is going to be running training in this case. We're going to use our Oumi distributed command to kick off distributed training. In this case, it doesn't matter as much because we're actually going to be running on one node, but we'll have torch run here, and we're actually going to be doing our training configuration here for our full fine tune. And the last thing to note here is I did actually modify our full training YAML here. You can see that I mounted our storage mount such that the /output directory is going to output to my GCS bucket. We can see in our actual job, we now have our output directory set to map to a subdirectory of that bucket. Okay, cool. So all that said, let's take a look and see how our job is doing so far. So we can see here we're downloading. Since we're downloading files, that sounds like we're still running setup. So in the meantime then, while setup is still running, I'm going to walk you through a few of the other commands that are available in Oumi and give you an idea of which commands you can use for orchestrating these jobs. So let's go ahead and do that. So I'm going to pop up in a new terminal window so I don't have to kill that one, and we will run some things there. So let's go ahead and let's conda activate Oumi, and let's cd to the right repository. And let's go ahead and show you some commands that are available for dealing with clouds. If I make this a hair bigger. Perfect. Okay, so we mentioned that we ran Oumi Launch up to launch a job. Let's show you the full dichotomy of commands that are available. So we have Oumi Launch, and we'll take a look at all the commands that we have. The commands are fairly simple. They're fairly straightforward in what they do. We can cancel a job. We can turn down a cluster. Turning down a cluster is going to completely erase the cluster. You're going to lose all of the bits that were there. This is the option when you want to completely kill it, remove all billing for the cluster. We can run a job. This is when I want to run a job and the cluster already exists. We can check the status of all our jobs. We can stop a cluster. This is like a pause button on the cluster. The cluster is technically down, but you're still paying for storage, so the storage will, be persisted. For clouds that support that, not every cloud provider supports that. And upping a job. Upping a job is the command we want to use when we don't necessarily know if a cluster exists. It will look for one. If it exists, we'll run the job there. Otherwise, we will create a new cluster and run our job on it. And finally, there's which. This is just a quick command we'll show you here, which will give you a list of the clouds that are currently supported by Oumi. So this is going to be Oumi Launch which, and we'll see a nice list of the cloud providers that we currently support there, which is, a local cloud, which is like a pseudo cloud for testing, Polaris, RunPod, GCP, Lambda, AWS, Azure, Slurm, etc. Okay, great. So let's actually go ahead and let's look at the status command so we can take a look at the status of the job we submitted. So Oumi Launch status. And what we expect to see here is we expect to see our cluster exist, but the job is probably not yet running. Yeah, we can see here we have our cluster for our cloud. So we have all these clouds, no jobs, no jobs, no jobs. We see for GCP, we do have a cluster that's established, but no jobs are currently running. Or have been scheduled because our cluster is still being spun up. It looks like I need to fix the, the coloring here too. That's a bug for me for later. Okay, so we'll keep an eye on things. Once that's good to go, we'll actually run a few of our other commands so we can actually interact with the job as it's going. Now, say, for example, I wanted to maybe queue up another job on this cluster. Once all of our run commands over here have started and the job has started, I can actually queue up another job. So to do that, what we could do is we could use either Oumi Launch up or we could use Oumi Run. So let's take a look first at the Oumi Launch up command since we already ran it, and we can actually talk our way through it. Oops, excuse me, I wanted help, not up, not C. There we go. So if you remember at the very beginning of this, what I ran for this other terminal running over here was Oumi Launch up -C and then a cluster name. So let's go ahead and take a look at the actual breakdown of this command. We can see I specified a config. This is a training configuration, or excuse me, a job configuration. I specified a cluster, and that was everything else. I didn't specify detached, so we're actually running in attached mode, which is why it's kind of eating my terminal over here. But everything else here makes reasonably good sense. Okay, now before we run out of time, let's go ahead and do something here. Let's actually go ahead and take a look at our status, because we see our job has now officially started. So Oumi Launch status, we expect to see one cluster on GCP with one job running. Perfect. We can see we have our cluster as expected with one job in the running status. So now that we know this, let's go ahead and actually let's just cancel our job. So we can see maybe something was misconfigured. We want to make sure we don't eat too many credits. Let's go ahead and cancel this job. So that's going to be our Oumi Launch cancel. And we can see we just need to specify the cloud, the cluster, and the ID of the job. So let's go ahead and run Oumi Launch cancel. Our cloud was GCP. Our cluster name I just copied. And our ID was job ID 1. So now what we're going to do is we're going to be canceling our job, and we should actually see this in sync. Both of our windows are going to show that the job has been canceled. So we know we're running. Oh, we can see that our job just changed over here, and we can see our job indeed was canceled. So if I run my Oumi Launch status, we should be able to see that we have a cluster still up, but with a canceled job. Yep, so we have one canceled job. Now we can do a few things from here. Our cluster will automatically turn down after 30 minutes of inactivity. That's something that Oumi has set for these clusters. But in the meantime, we could choose to maybe run another job. Or we can turn down the cluster, stop the cluster, etc. So I'll show you the command for that. We'll say maybe I want to fix an issue with my job, then run it again. So we can look at our Oumi Launch run command. This is just like Oumi Launch up, except we already know the cluster must exist. So we could specify our configuration, our cluster, and then run our job again. So let's go ahead and just do this over here, and then we'll cancel it again too, since I don't want to run a full training right now. So let's go ahead and do a run command, Oumi Launch run, specify this cluster that we know exists and our same job. We'll get that going over here. And we should see that this is going to copy our bits immediately because it's going to find our cluster that we know exists and submit the job. Great, so our job should be running, and we can verify that here with our Oumi Launch status. And we should see now 2 jobs listed for our cluster, 1 canceled and 1 running. Perfect. Now, as I mentioned, let's just cancel this job because we don't actually want to run a full fine tune for me, just so I don't forget later and get charged for this too. So let's go ahead and cancel that job. So we're going to run Oumi Launch cancel, and with our job ID 2 in this case. All right, and as soon as this job is canceled, I'm going to show you how to actually turn down a cluster. In this case, as I mentioned, we can stop a cluster, or we can actually cancel a cluster, but we're going to actually down our cluster completely. So what that means is we're going to actually make sure that the cluster is completely deleted and we're not billed for any of the resources associated with it. Let's go ahead and do that. So we will have, in this case, well, first, let me verify this for you. Oumi status, or excuse me, Oumi Launch status. We'll just show that again, our job has actually been canceled. You can see it on screen here, but we'll verify it with our Oumi Launch status. Great, we can see we have our cluster and both jobs canceled. So now let's take that cluster and let's go ahead and turn it down. So we'll use Oumi Launch down. And all we need to do is specify our cluster name, optionally the cloud, in case you have a conflict of cluster names, and we can go ahead and turn it down. So let's do our Oumi Launch down. Our cluster is this guy, and our cloud is GCP. All right, and we are now turning down our cluster. So once this completes, all the resources that were allocated for this cluster will be freed up again. This means if you were using quota from your cloud provider for your GPUs, that will be released, as well as billing should stop for any instances here. Of course, if you exported data out to cloud storage or buckets, you're going to still have to pay for that, but that is something that you should be aware of already. If you are storing things in cloud storage, you are, of course, paying for that. All right. So this might take, should take only a few seconds ideally to turn down the cluster, but you never know when it comes to cloud providers. In the meantime, actually, what I can show you is we should have some results from our jobs that had started in our bucket. So let's go ahead and take a look at those. So I did mention that I was outputting results to a Google Cloud Storage bucket. I have this available here. This was the bucket I was using. Let me just refresh the page, and we should see, yeah, we had some intermediary results that were output. So this was the local subdirectory that we had made for our jobs, and this should have output a few files. We can see our logs, telemetry, etc. are available here for us to view. So even though we've turned down the cluster now, we still have access to all the files that were generated from our training jobs. Okay, and now looks like our cluster is in fact down. We'll just verify that again one more time with our Oumi Launch status. And now we should see there should be no clusters available. And let's go up to GCP. We can see our cloud GCP, no matching clusters found. So what we've done is we've actually turned up a job using Oumi Launch, which in turn turned up a cluster. We canceled the job. We then ran another job on our cluster, and then we canceled that job and turned down our cluster. I also showed you how to get out the results from your job. We had streaming logs here on the left, and you can see additional commands for seeing the logs in the actual head node of those jobs. But if you're outputting things to Google Cloud Storage, a little bit more permanent space, you can go ahead and access those since we were writing those out to those cloud storage buckets. Okay, that's all I wanted to show you today. In a later tutorial, we're going to cover how you can scale this to other providers. So we've shown GCP, it's similar to do for AWS and Azure, but we know a lot of folks I work with, specifically in the research space, often have clusters that aren't on the cloud. So later on, we will cover how to do Oumi training and Oumi launching if you have your own cluster. We have a tutorial on oumi.ai/docs for how to do this for custom clusters or custom clouds, but we have actually done a few pieces of work, or I have specifically, for running this on Slurm or PBS clusters. So we already have pre-made clusters available, or pre-made boilerplate logic in Oumi for interfacing with those clusters. All right, so that's it for me today. And in the meantime, and until next time, happy tuning.